Hello and welcome to our video about stable and unstable power grid structures. Why is this topic relevant at all? In northern Germany is a shipyard which builds big cruise ships. When such a ship is completed, it is shipped via a river to the North Sea. In 2006, such a big ship was built that they had for safety reason to deactivate a power line which ran across the river during the transfer of the ship. The deactivation of the line created a cascade of line shutdowns and half Europe was in the dark. This is only one example why such blackouts happen from time to time. To understand what happened there, we have to ask, what is a power grid? In Germany, there are power plants in which wind energy is converted to electrical energy. What we call electrical energy, you understand colloquially under power. And there are cities in which electrical energy is needed. To transport the electrical energy from the power plant to the city, they have to be connected to each other. That happens through a power line. Now there are many power plants and many cities which have to be connected. So there are many power lines. And this altogether is our power grid. The electrical energy distributes itself not equable. How much electrical energy each power line transports is controlled by how much a city needs and how much a power plant supplies. Of course, each line cannot transport an arbitrary amount of energy. Each line has an upper limit we call capacity. By exceeding this upper limit, we do an overload by this power line. Because of security reasons, this line is then to be disconnected from the grid. The electrical energy that would have been transported from the disconnected line must now be transported by the other lines. Because these lines now have to transport more energy, they may be overloaded too. If those also fail, other lines must transport more energy again. If those also are disconnected, other lines are affected, and so on and so on. Because of such a chain reaction, the blackout 2006 happened in half Europe. So that does not happen, we need stable grid structures. This precisely is the occupation of the research group of Alexander Hartmann. Their computer simulations are used to study particularly stable and unstable grid structures. Let's look at a particularly unstable structure. Two regions are connected here with only one line. If this line fails, the grid is interrupted and nothing works anymore. Therefore, every network has to be constructed in that way to work even if one line fails. Grids that are not constructed this way, Alex doesn't consider at all. So Alex distinguished stable and unstable grids by another criterion. Let's just consider a structure in which each line is transporting as much electrical energy as it can because of its capacity. Let's view the worst case and imagine that the line that transports most of the electrical energy is failing. The electrical energy which was transported by that line is distributed again to the other lines. Since these already transport as much electrical energy as they can with respect to the capacity, they are overloaded by the additional electrical energy and fail as well. This would give us a blackout again. In order that this does not happen, the capacity of the lines must be higher. It must be high enough such that even the electrical energy can be transported which is added by the deactivation of the most heavily loaded line. The additional capacity that is needed is called backup capacity. This is the capacity which have to be planned as reserve, such that by the failure of one line not the whole grid is affected. Based on this backup capacity, Alex determines whether a grid structure is stable or unstable. The structure of a grid is the more stable, the less backup capacity is needed. So, the less the backup capacity, the stable the grid structure. Because Alex cannot build new lines all over Germany now, and he cannot deactivate or activate power lines at will for the research of the stability of different grid structures, he uses his computer, or rather more, the high-performance computer of the university in Oldenburg, called Karl. With this computer, he simulates different grids, investigates their backup capacity, and classifies them into the categories stable, middle, and unstable. The most stable is a grid structure in which everything is connected to each other. This is very expensive and complicated. Alex has now found out that structures with less connections are almost as stable. Here, once for all, smart fellows. Alex investigates how the backup capacity of a grid is depending on the amount of connections. His results can be represented with this graph. Here we see that with few connections, the backup capacity is very high and the grid structure is unstable. With a higher amount of connections, the backup capacity is very low. So this structure are very stable. Here we see that the backup capacity is almost the same for a very high amount of connection and fewer connections. So structures with fewer connections are almost as stable as structures which connect all with each other. Because of that, you can build very stable grids with less effort and less costs. One special feature of Alex results is that the backup capacity in this area makes a crazy jump. So that a difference of only a few connections makes the difference of a stable or an unstable structure. But Alex doesn't know exactly why, and that's why he has a lot more work to do. At least we can say Alex is collaborating with engineers to further improve the power grids, so in the future there may not be such blackouts as in 2006.